All right, so today we're going to talk about cell transport, and that's pretty much exactly what it kind of sounds like, is you're transporting things in and out of the cell. All right, so as you read above, there's a few different things that, or a few different ways this happens. We're going to be focusing on the one called passive transport. Okay, and in passive transport, there's something called diffusion and something called osmosis, and they essentially work both the same way. Okay, in passive transport, it's important to realize that it does not require energy from the cell. It just happens, right? So an easy way to think about this, and a good example of diffusion is spraying air freshener or spraying cologne, right? You stand at one end of the room, spray it. If I'm standing here, great drawing, right? And I spray my little can, it eventually will spread out through the rest of the room. Okay, that is when substances move from a high concentration to a low concentration. Okay. It's important to realize that these molecules will mix or they'll spread until they're evenly mixed, right? And that's something we call equilibrium. You hear the word equal in that. So molecules will continue moving until it reaches equilibrium. So let's go ahead and take a look at some examples of osmosis. All right, so osmosis is the exact same thing as diffusion. It's just really typically defined as the diffusion of water, right? We're still going from high water to low water concentration, right? So these are pretty easy to understand. Let's take a look at some examples. Some type of osmotic environments that we look at is something called hypertonic, hypotonic, and isotonic environments. Now these have a drastic impact on the effect of the cell and the cell size, actually. So let's take a look at these each one by one. Okay. So in a hypertonic solution, okay, there is more water inside the cell than outside the cell, right? So I typically in diffusion problems only look at the solvent or the water, the thing that's doing the dissolving, because it's only the water that'll move. Your salt, which is the NaCl here, that's too big. Remember we talked about that cell membrane can only let some things in and out. My salt, the NaCl, cannot get past this cell membrane. It's just too dang big. So to kind of even it out, right, to kind of make it even on both sides, what your cell tries to do is it tries to move the water back and forth until both concentrations are equal, right? So if I have a 90% solution here of water and an 80% high to low concentration goes out. I always remember that some of you guys are very hyperactive, right? Hyper children run out of the room, right? So we look at if my water moves out of the cell, my cells can actually decrease in size. There is a scenario where you have just the opposite, right? When you have too much water on the outside. If there's more water outside the cell than inside, right, 90 versus 80, my water goes from, again, a high to low concentration, and it goes in. And just like a big balloon, if it moves into the cell, it's going to get larger, right? And actually, if you look at the video above with the red blood cells, your blood cells can actually burst because there's too much water going into it. And again, this kind of thing, it just happens. This is how, like, when you drink water and you rehydrate, there's less water in your cells, you put more water in your arteries, right? So you're creating a hypotonic environment, and then boom, it rehydrates your cells. Last but not least, we have what's called an isotonic solution. Okay, think about an isosceles triangle, right? Great triangle, you have two of the same sides there. Same thing, iso means the same, right? So in the isotonic solution, you have the same amount of water and stuff, otherwise known as solute, in the cell. Now, it's important to realize that water is still moving here. It's just moving at in and out at the same pace, right? So that's like me saying, hey, I kick somebody out of the room and I drag someone from the hallway in. I still have the same number of children in the classroom. It's just there's a different mix, right? In isotonic environments, the cell's already at equilibrium, right? You hear the word equal there. Equal amounts of everything on both sides. However, you have movement in and out of the cell.